Welcome to Align Harder Academy. This is Richard Tai, and we're continuing our trigonometry lesson. Today we're in our trigonometry lesson 38. So last lesson we have been talking about how to simplify trigonometry expressions using the fundamental identities, fundamental relations. Today we're going to continue to do that. We are going to do several examples. So let's go ahead and start with some examples for today. Okay. Alright, so let's take a look at this example. Cotangent square x divided by 1 plus cotangent square x. Okay. Now, first of all, I recognize that 1 plus cotangent square x is Pythagorean identity. Okay, so by the Pythagorean identity, we can go ahead and change that to cosecant square x. Okay, 1 plus cotangent square x is equal to cosecant square x. Now, we have cotangent square x and cosecant square x, but it doesn't seem that they are related directly to each other, but actually we can go ahead and rewrite them. One way we can rewrite them is using sine and cosine, because both of them can be related to sine and cosine. As you remember, cotangent is cosine over sine, and cosecant is 1 over sine. Alright, so we have a complex fraction. Now again, we're going to be dealing with complex fractions a lot. So please remember, whenever you have a complex fraction, when you divide a fraction by another fraction, just go ahead, you can rewrite it. If you cannot see it directly, you can rewrite it as the multiplication problem. When you divide by a fraction, you multiply by its reciprocal. Okay, so as you can see now, the sine square x cancels out, this cancels out with that, and this equal to cosine square x. Another way, as you can see, this, if you divide this fraction by this fraction, both denominators have the denominator of sine square x. So when you divide them, the sine square x cancel out automatically with the sine square x. The denominator cancels out with the denominator. So you can you can see it right here as well. But this is another way to help you see more clearly. So anyway, so therefore this expression simplified down to cosine square x. Okay. All right. Let's try a few more here. What about tangent x minus secant x? Okay. Alright, so tangent x and secant x doesn't seem to have anything in common, but let's go ahead and write them using other expressions. We can write tangent as sine over cosine, and we can write secant as 1 over cosine. Okay, so now you have two expressions that both of them has cosine as the denominator. So this becomes sine x minus 1 over cosine. Okay, so this is one way to simplify, to combine the expressions into one fraction. Now, let's see. There probably can be other things that we can do, but there are many other ways that we can do this. We could go ahead and multiply this by sine x minus 1, sine x plus 1. But we'll probably leave it right here for now. Okay. All right. Let's go ahead and take a look at another example here. Let's look at this. Cosine theta times cotangent theta plus sine theta. Alright, so in this example, let's take a look at this, what we can do. Okay, so cosine and cotangent. So let's go ahead and convert cotangent to cosine over sine. And let's write sine as sine over 1. Okay, so here we have cosine squared theta divided by sine theta, alright, plus sine theta over 1. So as you can see, we have two fractions again, and in order to combine the fractions, we have to have the same denominator. Now the denominator here is sine, the denominator here is 1, so the common multiple is sine times 1. That's the easiest common multiple, which is sine theta. So we need to have a sine theta here in the denominator. That means we have to multiply the numerator and denominator both by sine theta in order for the denominator to become the sine theta. So this becomes cosine squared theta plus sine squared theta, and the denominator becomes sine theta. However, cosine squared theta plus sine squared theta is equal to 1 by Pythagorean identity. So it becomes 1 divided by sine theta, which is equal to cosecant theta. Okay? Alright, so let's go ahead and try a few more examples here. There are several other type of variables, but as you can see, there we are using different techniques. Okay, now let's go ahead and try this. Secant theta, cosine theta minus cosine squared theta. Okay. Now, first of all, I recognize secant and cosine. Secant times cosine is equal to 1 because they are reciprocals of each other. So this becomes 1 minus cosine squared theta, and this becomes sine squared theta. Okay, so that one was quite straightforward. Alright, let's try something a little bit more complicated. Sometimes you just need to use the algebraic notations as well. You have to use the algebraic notation to help you. Algebraic methods. Okay, like factoring, opening up a square. Okay, so take a look at this. Sine alpha plus cosine alpha squared equal to minus 1. So what would this become? Well, we got to go ahead and open this up. So we have to do use distribute property to distribute this to expand this expression here. So this becomes sine squared alpha plus 2 sine alpha cosine alpha plus cosine squared alpha minus 1. Okay. Now we can't do too much about 2 sine alpha cosine alpha now until later. Actually, you'll find out what that is. But sine squared alpha plus cosine squared alpha is 1. Okay, minus 1 plus 2 sine alpha cosine alpha. So the 1 minus 1 cancels out. So the final answer is just 2 sine alpha cosine alpha. Okay. So we used distribute property to help us. Alright, let's go ahead and try something a little bit more challenging. Okay, something that may seem more challenging, but usually involves fractions. Secant alpha, cotangent alpha plus tangent alpha. There are different ways to deal with fractions. So let's go ahead and take a look at how we work with fractions. Now, first of all, secant, cotangent, and tangent. Now, I know tangent and cotangent, they're reciprocals, but let's go ahead and convert them to in terms of cosine and sine. And let's see how does that help us. Alright, so secant is 1 over cosine, cotangent is cosine over sine, tangent is sine over cosine. So I can see the denominator, all the denominators are cosine and sine. So that means if I multiply by a common denominator both on the numerator and denominator, that will help us get rid of the complex fraction. So let's multiply cosine times sine on the top and cosine times sine on the bottom. Okay. So let's see how would that help us simplify things. So cosine times sine times 1 divided by cosine, so the cosine cancels out, so the numerator becomes sine. Cosine sine times cosine divided by sine, so it becomes cosine squared alpha. Cosine times sine divided by cosine, the cosine cancels out, so it becomes sine squared alpha. Alright, and that works out well because cosine squared alpha plus sine squared alpha equal to 1. So, by Pythagorean identity, so our final answer is sine alpha. Okay. Alright, let's try another example here. Sine A divided by tangent A minus tangent A divided by secant A. Alright. Again, in this kind of fractions, we want to combine the fractions. We want to have the same denominator, but let's go ahead and convert them to in terms of sine and cosine first, and see how we can simplify that. So tangent is sine over cosine, and secant is 1 over cosine. Alright, so in the first fraction here, we have sine over cosine. Now remember, when we divide a fraction, we'll multiply by its what? Reciprocal. So when we divide by the sine over cosine fraction, we multiply by its reciprocal. So the cosine, so the sine alpha, sine A cancels out. And same thing here. Sine A over cosine A, we multiply by the reciprocal, which is cosine A over 1. Right? So in this case, cosine cancels out. So finally, the expression is simply just cosine A minus sine A. Okay, cosine A minus sine A. Now, I'm sure there are other ways to simplify this, but right now I think that would be a good stop. We don't have to keep going. Okay. All right. I want to show you some other examples that require another different kind of method. So for example, let's go ahead and take a look. This is cosine squared beta divided by 1 minus sine beta. Okay, so how do we simplify this? Well, I know cosine squared beta, there are several ways to do this. I know cosine squared beta is 1 minus sine squared beta divided by 1 minus sine beta. Now, but don't make the mistake of canceling that 1 and sine right now. Okay, we cannot cancel them because they're not in factor forms. They're in expression form, so we cannot cancel them out. But 1 minus sine squared beta is factorable. 1 minus sine squared beta is 1 minus sine beta times 1 plus sine beta divided by 1 minus sine beta. The denominator doesn't change. Now we can cancel out this factor of 1 minus sine beta from the top and the bottom, so the final answer is 1 plus sine beta. So this is using an algebraic technique, using a factoring technique of 1 minus sine squared beta. You remember a squared minus b squared can be factored out to a plus b, a minus b times a plus b. That's where we got the factoring from. Okay, so this is using that factoring technique to factor. So that's very important. That's a very important thing that we can do. Okay. All right, let's try another one. I know we're doing a lot of examples today, but it's good for us to do several examples so that we can get a good idea of different techniques we need to use to help us simplify expressions. Alright, so you have sine theta plus tangent theta divided by 1 plus secant theta. Alright, in this kind of fractions, let's go ahead and again write them as fractions. Write tangent as sine over cosine. And let's write 1 over secant as 1 over cosine. So what I see here is I see the denominator has cosine in there. So let's go ahead and multiply everything by cosine. And then let's see if we can make this a simpler fraction here. So this will become sine theta times cosine theta plus sine theta. Okay. And here I have cosine theta plus 1. Alright. Now look at the numerator. Numerator I have sine cosine plus cosine. So we can use another algebraic technique called factoring. We can factor out the sine theta because both terms have common factor of sine. So if I factor out the sine, I have cosine plus 1 left. Now, but the denominator is already cosine plus 1. So the two factors cosine plus 1 will cancel each other out. So the final answer here will be simplified down to sine. Okay? So, again, we're just trying to use different algebraic techniques to help us simplify. Later on, this is very important too when we move on to the next topic. So let's try one more example here. Let's try one more example. Let's see, which one should we try? Let's do this one. Okay? Alright, sine squared phi minus tangent squared phi divided by cosecant square phi. Now this one actually is quite straightforward, because if you recognize sine secant square phi minus tangent square phi is equal to 1, right? Remember, secant square phi is 1 plus tangent square phi. So this is equal to, so secant square phi minus tangent square phi is 1 over cosecant square phi, and so 1 over that is sine square phi. Okay. Alright, so I think we've done enough examples today. We just want to show you different techniques. We have to use deal with fractions, how to add and subtract fractions, how to divide fractions. You have to remember how to do that, and also how to multiply, how to use how to factor. Okay, factoring is very important, and also how to use distributive property to simplify, to expand expressions. So all those algebraic techniques are still necessary when we deal with trigonometry expressions. And so hopefully today will give you a good idea of how to do some of the problems that we have to do. And then please practice a little bit more. Okay, I'm sure you can find other examples also on my website. We can post homework assignments that will have problems for you to practice. Hopefully you can master this kind of skills. Alright, and then so that's it for today. We'll see you tomorrow for another lesson in trigonometry. Thank you.